Okay guys, we're on our second part, which is our intro. Let's do this. Read the following description of an experiment. Ezra works for a company that produces wood varnish. He is currently evaluating how well the new varnish protects against sundown. Ezra paints 50 identical wooden squares with the new varnish and leaves them outside for 6 weeks. He takes pictures of the squares before and after the experiment to determine how much they fade. Is this experiment statistically well designed? I have yours a proof table, and this is the given. We can identify the variables in this scenario. While the independent variable is the new varnish applied to the squares, the dependent variable is the amount of fading observed in the wood squares after exposure to the square. Now there is a control group. There is no explicit mention of the control group with the wood squares without varnish, which is crucial to compare the effectiveness of the varnish. Its replication, that's why it uses 50 identical wooden squares which provide replication and helps in reducing the impact of random variation. So in this scenario, it would be called control variables. Now moving on to randomization. With the random assignment theorem, it is not clear if the wooden squares were randomly assigned to different conditions, or if they were exposed to the sun in a randomized manner, which is important to avoid bias. Now, moving on to measurement of outcome. The measurement here in this scenario is that Ezra takes pictures before and after the experiment to measure fading. This method of measurement is objective and quantifiable. So in this scenario, duration and timing. The duration in this scenario, the experiment runs for 6 weeks, which might be sufficient to observe some changes, but could vary depending on the intensity of sun exposure and other environmental factors. So I'm going to say that the final solution is because since this experiment lacks a control group, it is unclear if the randomization was used, which are crucial components of a well-designed experiment. It is not statistically well designed as described, but to improve it, Ezra should include a control group, unvarnished wooden squares, and ensure the random assignment of squares to different conditions. So in this not designed correct. So we're going to check if it's correct or erroneous. Yeehaw! We know it worked. That's how you do it, guys.